Well, welcome to the Dream Labs. I am Dr. Contrast, and we're live. Thank God. I really appreciate your patience. To those of you who are out there maybe listening, and then Terrace, great to have you on board. Great to have you always on Wednesdays. And we had a bit of a camera difficulty throughout the morning here. We couldn't get the thing to adjust, and the screen wouldn't come up. The camera, the sketch cam was malfunctioning. The desk cam was fine, but a lot of layers behind the situation that we had here in the office, in the studio, and we had to get that clarified, but we just got it fixed about maybe 10 or 15 minutes ago thanks to Shadow. So we're ready to fly here, and I thought it'd be kind of fun to kind of move into a little bit of a different format here today. We spoke about last week after we finished up some of that work on landscape architectural design. There's a lot of conversation about different techniques and different terms we use in putting together design processes in sketch work. I mentioned something last week about going through maybe a series of just educational things to kind of keep things tuned in and give us a really good footprint to work on in terms of putting together a nice set of series of sketches or things that we're working on. I think the first one I'm going to do here today is just, and I hope all of you will understand, I'm going to try and keep this extremely streamlined, non-technical, and as clear as I possibly can. Because when you get into things like platforming and perspective studies, putting proportions together, it can get really annoying in a hurry, and I don't want that to happen. What I want us to do is take a look at a very simple process, and the one thing I want to look at today is for transportation design, because it seems to be the most complicated piece of all in the geometry we deal with. They're all difficult, but transportation has one very secret little formula that we need to work with. That's how to cheat real well. I don't mean that to be demeaning, but learn how to take proportions and flatter them, how to lower it, how to widen it, how to give it more romance, and a lot more finesse to the sketch itself. But it begins by understanding the fundamentals and understanding what the techniques are for putting those pulses together. So what I'm going to do today is walk you through, hopefully, step by step, how to build a proportional on a platform base. Now, in the industry, we call it a platform because that's the area in which you begin to build your surface or area or vehicle, in this case, around. Platform is an absolute an area in space that we actually put the wheelbase down, select the tire frame, and then from there, from the ground down up, build that surface to develop a good sketch. So I'm going to start here with a very simple thing. Number one, there are two forms of perspective we're going to deal with here. These are really quick little loose sketches here. The first series is getting the horizon line down, selecting a central vanishing point, and that's where you're standing, for example. You're standing right there looking at this vehicle, or the architecture of this vehicle. Now, what happens is, once you get that set, you come down and begin to develop this first circle, because at one point perspective, there's no real, it's a facing plane you're looking at. This area right here becomes a facing plane, so you're looking right at it. So we develop one circle, count three back, tire, 1, 2, 3, plant the next one, and get that all squared away, and you're in. So that becomes your wheelbase. The wheelbase is from that point to that point. Now, the area in red that we're dealing with is a platform in which that vehicle is going to sit. That's its platform. So again, as we go through the exercise today, just keep in mind that that red area we deal with or working with is how the platform is setting up for the vehicle design of the architecture we're going to deal with. That's in 1 point. Now, in 2 point perspective, again, back to the horizon line. This time you kind of come at a vanishing point, right, and you create, notice the red area here, again, is a platform in 2 point perspective. Now you're standing, in essence, you're standing right here. That's where you're standing looking at this vehicle we're going to design. And when you look at that whole thing, this is called a leading edge. That leads you into perspective, into the actual shape. And what happens as well is that you have this as a drive line, that becomes a drive line, and everything goes back and forth to the vanishing point right or vanishing point left. So I'm going to go keep it real simple as best I can. Again, platform in red in 1 point perspective, platform in red in 2 point perspective. And then I'll go back in and show you how to begin step by step to put the platform down, build the wheels, build the body form, get the sections, and then roll into a certain shape, step by step by step. So there's step one. So let's go ahead and get that out of the way here. There's one. First thing I'm going to do, just out of theory, there's the platform going to sit right there. That's what I want to work with in space. So that's the area I'm going to deal with. Now, off of that platform, I'm going to come up and develop, the first step is to put things properly in perspective, to get the proportions correct. Don't be afraid to sit down and build a geometry of some sort. Now, after a while, this becomes second nature to us. And once it becomes second nature, So in 1 point perspective, you're facing the side of the vehicle, and in 2 point perspective, absolutely. And let's go back to this moment here. Absolutely correct, Terrace. Since this is a 1 point perspective, I'll go back in the future streams here and begin to develop the language structure for 1-point perspective and the language structure for 2-point perspective. That whole area right here is parallel to our eyes. So you're looking right at the side view of the vehicle. That is absolutely correct. That's terrific. Now when you rotate that or change or move it on the picture plane, you get this area here where this becomes a corner, and that's where you're standing, and that's on an angle. So instead of being parallel, now it just shifts to an angle on the picture plane. So that's the difference between the two here. So once I have that, I'm going to take it again, pardon me for being redundant, I'm going to write down through the step here and go right down the line with A, B, C, and D. Platform start. There it is. Second sketch. With that platform, I'm going to come back in and develop. Notice set by side here. I'm going to come back in and develop, in this case, the face of a cube. I'm going to start to build a cube off of that platform. Here are the corners. Those corners, pardon me, well, those little red dots are where we're going to start to plant the wheels. Pardon me. But to get that to function properly, we're going to first of all develop the face of a plane. In this case, a cube rather. This is the right-hand side of the cube. As it moves away from us, going to the left-hand side of the cube. So if we were to fill it in, all we're doing is building a cube in that corner. This is going to help us really begin to develop the whole rotation of getting the wheels in place and going from there. So once I have that, once I get that all set up, it's going to be, the next step is take it and begin to count back. For example, this is an area, there's one. This is where I started. Now I'm going to start to build the matrix. This is how it all come together here. I've got the actual face of the cube, the right side, the left side. I'm going to come back in, and once I have that set up, I'm going to come right through with this diagonal, right through that corner, right through the next step, drop that down, there's plane number 2. From that corner, again through, is plane number 3. From that corner, right back through here, plane number 4. So notice, 1, 2, 3, I've got 2 tires back or 3, I can build onto that depending on what the wheelbase is. So let me stop there for a moment. Is this making sense here, Antares? So far so good? Notice I'm staying inside the platform, but I'm building the whole matrix out to get this thing to kind of come together for us. As I go to the other side, what's interesting about that is this. You go to the left-hand side, same process. From this corner to that point of reference, run through it. There's your second cube. Again, down to the corner, run through it again. There's your third cube. Interesting. Most cases, what happens in vehicle architecture, you're going to see it's either 3 or 4 wheels between the wheels, and it's 2.5 wide. So if this is a 20-inch system here, you've got maybe a 50-inch, 60-inch width. And so far, down the line here, you've got 20, 40, 60, maybe about 120, 100-inch wheels base. So that's pretty standard. But we're taking this step by step to get the proportions right. At the end of it all, we'll show you how to begin to build this thing off of the geometry you've already set. So far, so good. So now that we have that, go to the third step. Now we're going to go back in and get a little serious here. Now, notice, I'm starting to fill in the volume now. There it is. There's the actual frame that it sits in. Notice what's missing in this sketch. Oop, and move this over just a little bit. Get this over there. Yeah, there it is. What's missing in this sketch is the actual backside corner or front tire, rear tire, backside tire, backside tire. Notice how we get here. Now, come back in. I take that same volume, that cube, and I project those lines through. There's my far side wheel in here. Over here, same thing, cube. Project that line through, get my far side wheel. What you'll notice is this, and I think I've got it in the next sketch here, just for a real brief moment. What you'll notice is once that architecture is set, I come right down and find the perspective center of that edge, and I drive it right back to vanishing point, right back to vanishing point, and I've got it. There it is. So that starts to set up the whole geometry of getting the wheels properly set, because I tell you what, I've seen more things in perspective, even professional design systems in studios, where the wheels are really off-center, and they're tilting when they're not quite properly correct because they're not working with the major and minor axes. We'll get to that a little bit later. You have to stand those tires up and inside that platform to make it all come together properly. All it takes is one little step along the way to destroy that whole system, and boy, it gets really tough to recover. So bear with me. Again, I don't want to make this overly complicated. Again, platform, set it up, the first cube, then build the depth and add the backside tires to it as you go. That's sketch number 4. And then let's move on to the next one here. The next step in the process is getting that down. Now, notice what begins to happen now. I've eliminated, in this sketch, I've eliminated all the in-betweens. Now I'm working with the front wheel, rear wheel, backside tire, front, backside, rear. At this stage of the game, I think it's really important to know. In this instance, did you eyeball the starting platform? I just imagined the vanishing. I just imagined the vanishing points and just laid down a platform. if that helps, Terrace. In this instance, did you eyeball the starting platform by just imagining that? Yeah, I just created the vanishing points based on where that platform sits. Just chase out the horizon line. That'll chase out the horizon line. Absolutely correct. So, once again, back to this sketch. I used that volume right there, front and rear, to develop where these tires are going to fall. Now I isolated the in-betweens. This is now my perspective center, going back to vanishing point right, and then I can come back on this side, back to vanishing point right. That's the cube, but I want you to notice something here. Notice how this wheel right here, look how tight that is. As it goes back, look how it diminishes. So it's wider, then it narrows down as it goes back rearward. By the same token, on this front tire, as it moves away from me, more to my left, how it opens up. This is going to be a lot wider here than this one will be here. And because of the circumstances of visual space, what happens is this. Interesting now is this. That area here is almost identical. It's almost in the same plane as that left side rear tire. So let's put it down in a figure form if it helps here. If this wheel is at 45 degrees, that one's going to be at 35 degrees. If I move across here, 45 up to 55, it'll open up, and then this one back here will be the same, 45, 45. Once again, that's what happens when I see circles or tires being done, or just round forms, whether it's product design or whether it's architecture, interior space, no matter what it is, even landscape work. What's interesting is that we always draw those circles the same scale as we go back, the same size. It doesn't happen. Look at your car very carefully when you go out there, for example, in the parking lot. Stand at front three-quarter, look at the front wheel, and look at the rear wheel. You'll see that if it's 45, it'll shrink back 10, add 10, equal. That's really a good thing to look at here. And we'll show you as we go down the line here with these sketches how that begins to function and what it looks like. So, once again, full architecture. Now I'm starting to pare out what I take out what I don't need and begin to work on the elements that I'm going to work with. So there's sketch number 5, come across, and let's put that one in place. Now, well, I'm starting to put this whole thing together. Here now, this is an interesting page here. From that setup, again, with the same, same platform, now I've got my major axis, my minor axis. Major axis, minor axis. And if you notice real quickly here, oh wow, I never noticed that the first wheel so far as that shape. Yeah. Wow. I never noticed that the furthest wheel is so similar in shape to the closest. Yeah, that front side tire, Terrace, if that's at 45 degrees, the reason that's true is if I'm standing here, I'm very close to that same eye window. So what happens is 45 and 45, that's almost equal. And by the time you never see it, but at least laying out the geometry, if you understand these principles in your mind and begin to see it, it's just executing it so much simpler because you begin to open them up and close them down where you need to. And it looks correct. There's nothing worse than doing a piece of architectural work in an automobile design when the wheels look like they're falling off or they're too thin or they're the same size. It just falsifies the whole sketch. When I was at General Motors design staff, we used to really hammer home with the young students coming in. Let's get those proportions right, because if that doesn't happen, width to length, wheel to wheel, and so on, it destroys all the value. For example, if the engineering comes in and says we're going to do a new Corvette and the wheelbase is X and the width is X and the overall height, that can be laid out very quickly in perspective, and it always looks accurate. Why? Because when you do that accurate sketch or that layout, then you put the full-size clay, they're all set. The proportions are equal. You don't have to go back and adjust. So I'm a big fan of doing it once. Do it once and do it right. Then all of a sudden, everything else falls into place. And then from that, you build variations on themes. So much easier to work with. So let me stop here for a moment. And Terrace, does that answer your question? Good? Yeah, you'll always have that front wheel and that rear wheel will always be just about visually equal because they're almost in the same plane. That's what happens. So very interesting. It's good stuff. Thanks for a great question, by the way. Excellent question. So, let me move along here. Again, full body. Now we've added, for example, I've got my horizontal in, I've got my minor axis in, but not my major. So now that I've got this all set, there's my minor axis, major axis. And really when I'm at it, that major axis always stands up. That's the vertical side. I notice sometimes you see this in publications or magazines. You'll see, for example, just find a perspective center and then build your circle or your wheel off of that. Well, it tips it. It's totally incorrect. Go out and look at your car again and see if that wheel, that front wheel, looks like it's actually leaning or tipping. It's actually standing upright. And that's what gives you that major axis piece here, because that's orientation. The major axis gives you orientation. The minor axis gives you direction. And there's another thing called axle. That gives you rotation, how to begin to spin a wheel around that. So we'll get into that more as we go down the line here. So there's a sixth step in putting this whole process together, getting the wheel set. And then now next step is we come back in, and this step here, you move into it. Now this is where we're at. Now look what happens here. Here's my framework. Now major, minor, I start to lay the wheels in. One. Again, notice how this is wider, narrower. This is narrower, that's wide. It opens up just enough. At 10 degrees makes a big difference when you plant those wheels. Enormous. So once it's making sense here, Antares, am I going too quickly? So far, so good? Again, I don't want to belabor this to make it all so complicated that, oh my God, what's the guy talking about? I want to keep it nice and simple, based on two simple principles. Number one, setting the platform. Number two, working with cubes to set up the proportion. And then you begin to develop the circle in perspective. It's just actually three elements, I'm sorry. It makes a huge difference. I see what you call axle. I have called the minor axis before, which confused me. Yeah, the minor axis is always going to be this horizontal right through here, Antares. This will become your major because it's vertical. Again, orientation. Minor axis will give you direction. And then the rotation, the axle, that blue line right there, let me do this. Let me extend that just a bit here. If I take that same line and extend that line and that line, those two limit, that line there and that's my axle. That's where I'm going to rotate the circle around it. And I want you to notice something else too. Notice you've got, let me heavy these up. I've got 1, 2, 3, 4, which I call contact points. When you come back into that, look what happens here. That you rotate. When you rotate, contact, 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 contact. You contact those 4 points to give it fullness, and you've got it. Now let me stop there again. That's a good question, Antares. Am I clarifying things okay? Does that make sense? A lot of moving parts here to make sure we're all in the same page and just making certain that certain things come together for us here makes a huge difference. Again, it can become an absolute nightmare if these processes aren't followed. And after a while, like I said in the very beginning of the stream too, the more you work with these fundamentals, the more you begin to see things in your mind's eye, and it develops a mental picture. It really makes a huge difference when you see it mentally, because when I start a sketch, for example, the first thing I look at, first thing I see, it's not the automobile. I see the geometry. I see all of this stuff. Then I build out of that. And that's the hope for this whole stream today, that we begin to use these fundamental tools of truth in visual geometry to develop really interesting sketches and accurate sketches. It doesn't take grab a piece of paper. Let me show you something. I'm gonna use it. I'll use this a little bit later on here. Show you a couple of demo pieces. So there again, there it is. We've got the locations in. Now we've added the tire geometry to it. That's the 7th step. Now we're gonna come back in through here. Now we come back in. And the cool part is now, guess what happens? As a result of that, we begin to move to this. Look what begins to happen. We move that down. Then we move this down. And this actually, right here, that vehicle is laying in a sketch over the top of that geometry right there. Now, it's not the greatest design in the world, but I'm not here to design it. I'm just using the fundamentals to get it all put together for us. But again, I want you to notice, look where the platform is. Same thing, that has not changed. That location of tire right there, that one is the same one that we just did here. Let's draw through it. That tire is the same as that tire. That tire is the same as that tire. So all the geometry I've got out there squared away. This is just a simple little pencil sketch to give me a nice operation about how to go from step 1 to 2 to 3 to 4 to 5 and so on down the line. So what begins to really happen here is, again, notice I've used that. I can come back in here, pardon me for a moment. Let me just do something real quickly here. This is where my far side tire ends. This is my leading edge here. How I found that center is doing this. That center line was created by doing the following. Let me just move this in here. I created a plane, found the center of that plane, which is right here, dropped it down to ground and opened that up. That comes right through the middle of the platform. That tells me where I begin to move my section, right through here, up into the upper, into the tail section. Again, proportion over the front wheels, insert, far side width, and then notice, projecting all the way through, projected, 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 all going back to the vanishing point left. These are the things that really make a huge difference and putting those sketches together, it's monumental. You can't forego it. You can't falsify it. You have to understand, and let me rephrase that, it's really a good discipline to understand the geometry of all this stuff so we know where we're going. I've always said this in previous streams, I'd rather know where I am as opposed to guessing where I'm going. When you guess at it, that's inaccurate. But when you know where you are, that's a whole different geometry altogether. So that begins to really open up the whole idea of what this whole thing about platform really means. Platform to me is a very, very solid statement and process to work with because it secures the object you're dealing with. It secures it. While I'm at it here too, let me just interject this thought. For transportation design, we always refer, let's get the platform set and then build up from there. But when you get into architecture, that platform is no longer applicable. Architecture uses the term footprint. So they look at the plan view only, and they begin to look at the footprint of the building, and then from there they begin to build the surface, almost like they're doing layering or subjecting it to a transfer and molding it and extracting it out, extruding it out of the actual plan. We'll get into that later. I'll do maybe another little educational piece on architectural work. Same thing for interior space. Interior space does not work with a platform. They work with, again, with a footprint. What does the room look like in plan view? Where are all the elements? I mean, from that they begin to extrude out of that the actual interior shape itself. Now, what does share the same term platform is product design. You have a platform and a product design, getting the whole thing idea, just going down how it all begins to take advantage of a platform is maybe you're doing a hand drill. Here's the width of the hand drill. It's got this center line. It's got this circle in it, and you can use that as a proportion base. And my point is, I hope that I get this across. And if I don't, then I failed today. What we really need to focus in on at all times is understanding the geometry. It should be captivated in our visual system. And you don't have to go through all these steps all the time. I'm not stating, for example, every time you draw an automobile, you go through all these steps. I just want to simplify it down. Start with a platform, add the geometry, add a cube, add the centers, add the major and minors, add the wheels, and so on. Just to add to it, and then let yourself become that footprint. Let yourself see that footprint. So your sketches become so much more powerful, and it happens just like that. I don't know you, but I've seen things in squares. Just getting it all set up there, Terrace. When you put that into a process, it's just amazing how it all begins to function. It's great how it functions because it's truthful. You can't deny the truth, and you see it in your sketches. They will know. Again, I want you to notice this. Look at that. I'm going to put a point right there. Look at that contact point, and look at that contact point. That's standing upright. Let me just hold that for a second. Let me just put that on top of that. I'm going to come back to this in a moment. You tell me which is more accurate. This, where you actually, this is what's taught. Here's A. I come back in. We get that face of a cube. What they tell you in publications is, all right, now just find the perspective center. This becomes your major axis, and this becomes your minor axis. Totally false. As we said before, all that does, and then they tell you rotate your axle or wheels around that major axis. Now, if this is my major axis, watch what happens. Major, and then this is now minor. And they always use the term for example. The major's axis is always a longer one, and the minor's a shorter one. Out of that, all that does is help me find the perspective center of the face of that cube. That's all that does. Now, if I do this, now this is my major axis. And this is my minor axis. Let's go back to that first one. Let's sketch around this guy first. If the truth is that the major is a diagonal and the minor is another diagonal, and then spin around that major axis, look at this. Look at the contact point. Does that look like it's tipped to you? Does it look like it's kind of skewing off to one side? Absolutely it does. However, let's do this. If I come back in and say, okay, using that same system, I get the face of that cube in, pardon me. I get that in place. Now, let's find the perspective center. Very lightly. It's that to that. Perspective center. Minor axis. Major axis. Point of rotation, point of rotation, point of rotation, point of rotation. You tell me. What looks more accurate? See what I'm getting at? How that leans? This stands upright. Here's another thing. Let's do this. If I add the other side of this guy, and put the other side of that perspective of this cube, and I add that to it, and I take that same minor axis through here. Here's my minor, going to vanishing point left. And if I come right through the center of this thing, right here, that hub, if I draw a line parallel to that, that now becomes my, this is now my helping, that's my axle. Helping? Why is that important? Because now, if I want to build a tire off of that, now look what happens. I go outboard, I go inboard, I go wheel design, done. See what I'm getting at here? It all works together. It's truthful. You cannot destroy, and you can't debate the truth. Let me stop there for a moment. I hope that's helping, Terrace. I don't want to go too far here. Pardon me, my voice is going to cracking up a little bit, so pardon me for hesitating. But what does that, look at that does. Isn't that amazing? Again, one more time. Here's my initial circle in perspective. If I use my axle, I can come out here and do the following. Tire, take it. Now, if I cut a section through there, now it's this. It's this, going into this, back out through that. Now vertically, this, going into that, and back out again. I mean, look at the difference in geometry there. Phenomenal. Same thing if I lay it all down. If I go the other way, for example, if I lay that whole thing down and open it up in the other way perspective and put that together. Now this becomes my, let's find the perspective center. Drive it back through. This is now my major axis. This is now my minor axis. Again, contact point, contact, contact, contact. Rotate. Bam, there it is. Now if I come up out of that, now my axle is going to go vertically. Let's kind of put that in place, just vertically right there. If I come out of that axle, I can go inboard first, and come back outboard, come back again, and notice, the closer I get to the horizon line, the flatter that gets. There it is, contact points. I mean, again, look, again, contact point is here, here, and it's all over the place. It warps that to that. It might be true there, but again, it just tips that whole thing. Whereas this guy, it's vertical, horizontal, horizontal, instantly. And in just a moment here, let me just show one little trick here. When you get to that place, here's what happens here. When you get a platform set, you can get to the point now where you actually can do this. You can actually go back and say, all right, let's do this. I'm going to go here. Put a drive line down. Go back here. Go over here. Drive line. Get that set up. Find my center line. Draw through it. There it is. Now, see what I did there? Sketch first, but no, all the while I was seeing this. This is what I was focusing on. That was my platform. That started, here's my leading edge right here. Here's my leading edge right here. There's the box form coming in. There's the first cube face. Backside, look how much that diminished from that dimension right there down to that dimension right there. How much it really reduced itself. Once again, if this is 45 degrees, that's going to be 35 degrees. This over here is going to be 55 degrees. And the backside that we don't see, same thing, 45. But to know that helps keep things honest. Let me stop right here. What do you think, Antares? Is helping? I don't want to go too quickly here, but I just want to make sure we can get these points across. 3 things that are really critical from the whole idea of getting proportions down. And the accuracy and putting, especially in transportation design. Think platform, number 1. Number 2, build the cubes. Number 3, get the majors and minors down. Then get the circles in place. And follow your center lines and get that thing to work on through. Let me go back to the sketch here for a moment. Let me get this out of the way here. Let's put these 2 together. One more time. There for that. If I get these back up on screen, thank you. So let's go there with that guy. Let's go here with that guy. And then to give you some idea, here's again an explanation of getting those faces down. Incorrect, 100% accurate. That's geometry. That's truth. You can't debate that. Look at how the whole thing works. No matter where you go in space, that whole idea of getting circles down. I mean, the thing that always bothers me, and when I put lectures on or workshops for young students or college students or even working with companies on consignment doing project work, they always use the term ellipse. I stop them. It's not an ellipse. It can't be an ellipse. An ellipse is a 4-quadrant, equally equal sweep. But we can't go in perspective because all it is a frustum through a cone or a cylinder. It's actually equal all the way around. But when you move a circle in space, it rotates and changes proportion. That's where you get this. That's where you get this. This one sketch here. I lost it. I think it's back here. I think that's where you get this again. 45, 35, 45, 55. That's where it shrinks, expands, and closes. How do you determine the degree of the wheel? Well, I think you can do that. I think you visualize that absolutely. You can assign that, for example, as it moves closer. Let's use this page right here. All right, so let me get this. I'll use this page here, just for what it's worth. You anticipate that if I have an opening, for example, if I start a wheel here, and I've got almost that kind of proportion to it, I would call that just about 60 degrees. How do I know that? I come right off of my horizon line here. I've got about maybe 30 degrees of perspective, which means that's a 60-degree wheel. On the other hand, if I come back in with this and have a real tight proportion like that, boy, all of a sudden, that's about a 30 to 45 degrees. Look at that guy. So you visualize, depending on the face of the cube, you can dictate that any way you want to. The idea is, if I could call that 60, I go back to 60 down to 50. I mean, you can dictate that. The idea is to always remember, closest wheel, fuller. As it goes back, it narrows down because of the depth. And then this reason this backside wheel here, let me do this. I lost my one sketch here. Yeah, the reason this backside wheel is so critical, let me get this out of the way. What happens is, as you move across the picture plane from there to there, that whole surface is opening up. So as you open that up, all of a sudden it changes dramatically. Helping? Just going right through here and open that up. Let me give you another example of that right here. If I were to draw a cylinder, and it looks like this, I'm going to come back in and draw a cylinder. If I come back in and draw that first cylinder form like this, and if I come back in space and go here, this cylinder is closest to me, right? But as I move away from that cylinder, if I step from here all the way over, let's say I move over about 10 feet, that's going to look like this. Look how much that opens up. Again, if I drive that through major axis, the minor axis, and then run that through, same horizon line, same setup. Again, take that through. There's my minor, and there's my major. I can come back in and recess this. Come back in and recess it again. I can come back in. Now, what's cool about this, I can build, this is what help build a product design off of that. I can come back off of this and just have to and so on. Look at the difference between this and this. That's correct geometry. So you measure the angle from the horizon. Yeah, you can from the horizon line, or even from the ground line too. Right? You can actually from right here. You can actually measure it from right down here too as well. But I think the better method there, quite honestly, Terrace, is to just lay down your sketch and imagine, for example, if I've got a really wide open wheel. Let's do this. If I have a really wide open wheel, for example, I'm going to say that guy, and then back to ground line here, and I open that up to that. That's one. I can say that's maybe 55 or 60. I can just tell myself that's open, so therefore it's a little bit larger. However, if I do the same thing and I tighten down that perspective by doing this, and I really tighten that down, whoa. See the difference? I'm pretty light sketch there, but let me see if I can get this up here. Does that make sense at all or not? Let me heavy that up so you can see what I'm doing here. If I open this up, much wider, much narrower. If I put a bone line in here, if I come through this thing, etc. Look how wide that is. Helping? That helps. So wider, smaller. If I go back to this one, much tighter view. There it is. Help that make a difference? Cool. Got it. Excellent. Nicely done. So that kind of puts it in encapsulation form here. We're going through the process. Let me get rid of some of these sketches. And then last but not least, I'll take this a little bit further in scale here, a little bit larger in size. And I took just a moment for a second here to kind of put this in a liberty of some sort. I did a couple of sketches here to show you again the variety of what Platform does, and then we can wrap it up from there. So here again, a couple of real quick, larger sketches, ballpoint pen studies of how getting into, for example, look how narrow this platform is. Narrow down the ground. It's almost just a little bit above eye level. Once again, and Terrace, look at this. Look how much fuller this circle is here, and how much narrower this circle is here. Wider, narrower. Helping? Just about there. So again, notice, once I've got that platform set, what I've done here is this. I've taken that same cross, come right through and find my perspective center, drew that through. I use that line right there to tell me where my center line is, right there. So that tells me how to build that shape off of that center line right there, right through the entire farm. I don't see that one over here, but it could be right about there. So there I am. That's seeing through the object. I think that's one of the things when I do a lot of sketches, every one of my sketches, I've always had the habit, due to great training from guys like Sid Mead and the like, to see through it as if it were a glass object. Visualize going through it so you see the accurate forms properly here. So that's one approach. Now this is a much tighter, that's the ground level. But what I want you to see is this. Even at your ground level, that's a circle. And that's a circle. There's my connection line here, and I've got 1, 2, 3.5 wheels in between. So even at the ground level, you still have a platform to work with, but it tells you where that backside wheel is going to go and where that backside wheel is going to go because you know where that ground surface is. So let me stop right there for a moment, and we'll come back in here and do the following. Well, last but not least, those are basically 2-point perspectives. Very shallow here. Look how very subtle little shallow 2-point. Even though this is almost an elevation, it's a 2-point study because that trails off the vanishing point in the left-hand side. So let me just do this. Get rid of that guy. Now here's another example of how, look how the geometry through this sketch is working. Helping, gang? What do you think, Terrace? Making sense now? Here we are. Notice again. Let's go right back to the first sketch we showed you today. Here, let me go back through this volumetric. Let's go back to this. That will help. Or is it the next one? Nope. Pardon me if I find that sketch, and I'll relate it here as best I can. Platform. Second platform. Yeah, this will help. Let's look at this. Look at the difference in geometry. Look how I use that, even though it's in two-point perspective. Notice how I use that form to develop the center line, minor axis, minor axis. Even though this is a one-point study, same process. Face of a cube, face of the cube. Major, minor. Develop it through. This block goes through, that block goes through. There's my far side wheel, my far side wheel. Now in this case, just to emphasize how strong this platform, look at the platform here is in red. It's going to be, that platform is there, to there, to there, to right through there. There's my platform. I'm building that whole vehicle around that platform. So once I get that all set, notice, again, right back down here, here's my center line. Off of that line there, center line, to center line, down to center line, and then right down to ground. Right back from that point, right back to ground, right about right there, underneath, right there. That I built this whole sketch off of those three components. Number one, the platform. Number two, the tires. And number three, the center line. And I built that right and left off that whole. I just extruded to the right and extruded to the left. And there it is. So that's a little study here on how to put those surfaces together. And notice, I hope I can close with this too. I hope this has not been too boring or too technical. What do you think, Terrace? Please be honest. Has this made sense? Has it helped? There you got it. Absolutely terrific. Absolutely terrific. Good job, man. So, anyway, now, but again, the explanation, and I hope I didn't go too quickly from step to step to step. Did I make it pretty clear as to what was really taking place? I hope. Because it can become extremely annoying and intimidating, because I don't want it to be that. I just want it to be very structural, very simple, and very useful. So when we look at this stuff, we just get all these pieces put together. It's really worthwhile. So thank you. So I think what we'll do here is wrap this thing up here today, and I'm going to convert this into, take some steps on this and get this into a lesson platform. And maybe next week we'll take a look at the same thing from like building footprints and how that begins to operate. Take a plan view and show how to rotate that and build a structure off of that as well. This to me, discipline, and I hope I'm not being favoritism here, I'm not utilizing favoritism. This to me is the most difficult situation to deal with because it's so commanding. There's so many components working with it. And a really simple, you get very simply caught up in a lot of confusing areas that can destroy your sketch or ability to see and visualize forms. So the whole idea is to get used to seeing the whole, again, like we said last week, knowing the end from the beginning. What's your vision? Lay it down on a platform. Build up the structure. Get the faces of the square of the cube in place. Begin to develop the wheels, and off of that, develop the shape. You've got a ground plane to work with. It'll always bring you back to a surety. So again, if I were to close with this, one lesson plan I'd like to get across, or one thought behind it all, would be this: always know the end from the beginning. Know the end from the beginning. That doesn't mean it's going to be perfect from start to finish, but know what your vision is, and then chase it on through using good fundamental technique to get it done. So all that to say, thanks so much. I was really pleased. I was a little bit concerned a little bit earlier today because we had some camera difficulties. The sketch cam just would not function. We got to shut it off and do some rewiring work, and thanks to Shadow, we got it put back together again about just 15 minutes before showtime. So I really appreciate his efforts, and I really appreciate you, Antares, for tuning in here. Hopefully this has been of some help. Don't forget to send me some of your sketches. I'd love to look at it and work back and forth and do some cool stuff with your material. And again, so grateful for the fact that all of you watching, much appreciate this. So this will be the first of many little instructional pieces, and I'll keep every one I do, I'll keep it very simple, very tailored, and hopefully very effective in putting it all together for you. So before I sign off here, please take a look at my website, drcontrast.com. Take a look at it, see what you think. Let me know how you feel. And secondly, if you have any things you want me to work on, for example, Antares, specifically, just drop me a note at jim@drcontrast.com, and we'll go from there and build on some things. And again, thank you so much for your loyalty. Appreciate you being on board, Antares. Your input is really very helpful to me. Always has been and always will be. So thank you so much. Take care of yourself. Have a great week. And last but not least, always remember to dare to be great, because you are. All the best, gang. We'll see you next Wednesday. Thank you.